Okay, kia ora. My name's Catherine Watson and I'm the Director of Software Engineering in the Department of Electrical and Computer Engineering, and I'm here today to give you a little bit of an outline of what you might expect as a software engineer. So I'll talk a little bit about why it's important, give you a sense of some of the things that software engineers do, and actually how we here in the degree that we offer at the University of Auckland, how we prepare you for the challenges in the profession. And I also touch briefly on how the degree differs from computer science, because that's an often asked question. So, why software engineering? Well, I thought this is a really nice quote from a 2015 article which states that software engineers are part of the foundation of virtually all sectors in today's economy, from something as small as a smartphone to something as massive as a telecommunications network. Software engineers have a direct impact on our everyday to-day lives. All engineers do that. All engineering is about creating infrastructure so that we can have our societies and our civilizations. And now software has taken its place amongst the other traditional engineerings like civil and mechanical. Okay, so it's all about creating infrastructure. A more whimsical quote about software engineering, which I really liked, is this one from a software engineer called Grady Booch, which says that software is the invisible writing that whispers stories of possibilities to the hardware, and the software engineers are the story makers. So, as I say, it's very whimsical, but I hope in the next few minutes I can kind of give you a glimpse of why someone might say something like that. So I think the first I'm going to show you is just a small portion of a video about the Internet of Things. Now, the Internet of Things is a huge computer network infrastructure, but it's all about software, and what we're going to see and what to look for here is how the software is linking all of these different sorts of components and devices. So we'll just see how this goes. Can you hear that at the back?
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data, and how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can
it goes on. It's quite an interesting video, and I encourage you to look at it. What I wanted to get across to there is the large infrastructure, okay, that's all linked with software. It's got to be robust, it's got to be reliable, and it's got to be secure. Okay, so that's a sort of a whimsical look at software. Let's sort of look at some hard, fast examples. So the kinds of places that our graduates have ended up, this is just some of the very few, in games development and special effects in movies, sort of whole sort of housing, putting information into databases and then distributing it. It's a huge area. The whole way that these software devices look, okay, the whole user interface, okay, that's not a trivial thing, how to import and work with the user. These have got to work on computers, on smart devices, on mobile phones, on tablets. Okay, so we talked about the Internet of Things. Now we're bringing into it actually virtual reality, and that's actually becoming a big part of sort of software engineering and information providing. Health IT is another example of where our graduates go. This is just actually a very small example. What I wanted to do is now go on to sort of give you a few examples of sort of some big software engineering tasks in practice, and look at what the engineering challenges are and actually the skills that we furnish software engineers to address these challenges. So the first one I'd like to talk about is our local national success story, which is TradeMe. Now TradeMe is New Zealand's 5th most visited site, which you might think, okay, 5th if it's like the Flight of the Conchords being New Zealand's 3rd most popular band, but the thing is that the top 4 are the likes of Google and Facebook. So this is a homegrown web platform, and all the infrastructure is within New Zealand. Okay, so we're sort of used to the TradeMe site now. This is a very busy site. Okay, there's millions of indexed documents, hundreds of thousands of simultaneous users worldwide, and the experience for all of them has to be the same. It has to give 1-second time responses, because that's what we demand now as users, and it's got to work just as well within a resource-rich part of New Zealand like Auckland, or where the infrastructure is not quite as strong as out in, say, the back blocks of Golden Bay and the South Island. It's all got to be the same user experience. Okay, we take for granted how well these things work, but that's because engineers are doing a very good job. Just at another level, take our lights here, okay? When we turn on our lights, I bet none of you go, wow, that's incredible, the lights work. But in fact, that's an amazing engineering feat. The infrastructure that's gone into making those lights work, and you just take it for granted, is huge. And it's the same with these sites on the computer, and it's the same with these software engineering infrastructures. They have to work all of the time, and that's a mammoth challenge. So in order for that to happen within New Zealand, for TradeMe, there's 2 data centres in different parts down in Wellington. It's got basically these data centres, which are in physically different places, are full up of heaps and heaps of computers, hard drives, CPU. They've all got to talk to each other. There's massive distributed database architectures, so that if one part of the data centre goes down, another part can pick it up, and it's a seamless experience for the users, and they aren't aware of that, what's going behind. In order for the data to be shared, there's got to be massive computer networks that are enabling this to happen. On a daily basis, the TradeMe sort of network, if you like, is capable of sending up to 4 terabytes of data and having more than 2 million emails daily. Okay, that's a massive amount of engineering that if something goes wrong, it can really affect the user's experience, and things will go wrong, but the way that the engineering happens ensures that for the customer it's a very smooth process. The web platform itself needs to be quickly scalable because of the fact that at any one time you never know how many users you're going to have on the system, and so the system has to work really well with a million users or just several thousand. TradeMe has heaps and heaps of images there to keep for the selling purposes, and these take up a lot of space. The image servers need to hold up to 60 million live images at any one time. So there's a lot of data and infrastructure that has to be delivered constantly in TradeMe. So the kinds of software engineering challenges are things like high numbers of users, massive parallelism. Things are having to happen on multiple computer systems at the same time. The data is distributed again across many machines, and so that all has to be coordinated. The results that are given to the users have to be good, but what does good mean? Okay, so as engineers we need to understand what that means and deliver that to the users. In order to create these things, you have teams of engineers working together, not individuals, teams of people building complex software. So when you come to study with us doing software engineering, we teach you about software architecture, we teach you about computer architecture, about parallel computing, database design, machine learning techniques. And then there's the generic, but very important, actually core of what it's about, being an engineer, generic engineering skills of teamwork, communication skills, and then being able to develop large software platforms. Okay, so these are ones used by multiple users. All of those skills we teach you here at the University of Auckland in our degree. Another example of a locally grown software system is that developed in Orion Health. And so this, in one of the systems that they have here, they have developed a platform which is cloud-based, which enables users quickly to send accurate patient information to other health providers and even the users themselves, the patients themselves. And so in this sort of situation you can see that security is huge. Okay, that's a huge issue. But also is the presentation of that data, because you've got people of varying technical backgrounds having to use the complicated platforms and having to access the data. So the kinds of software engineering challenges in a platform like this, again, is the use of databases. It's the fact that the information has to be displayed and accessed by a number of different devices, smart devices, mobile phones, tablets, computers. Software architecture, how it's designed, is very important in this situation. Again, user interfaces. The engineers need to be aware of the kinds of users they have and how they provide the information. And again, these kinds of packages are developed not as with individuals, but in huge teams. So you've got to have good communication skills, you've got to have good software development tools and processes to create such devices. And again, in the software engineering degree, we teach things like software engineering processing, software engineering methods. We focus on teamwork. We have courses in interface design, in software architecture, and also in huge systems like this, there's a lot of testing that has to go on to make sure that you've got what you think you've developed, and we teach how to do rigorous testing of your software development as well. The final example is, if you like, beyond the Earth. This is actually software engineering and its use in the Square Kilometre Array project. So this is a science project, but it's a massive international undertaking, and sort of showing again how software engineering's ability to create this massive infrastructure is key to the success of this project. So in this huge telescope that they are building, it consists of, sort of hundreds and thousands of these antennas, which have to be all coordinated. Now, the major challenge in this project is that the amount of data being that's going to be captured is huge. More than 150 terabytes of data per second. And basically, this is what they're getting is 5 times more than the global internet traffic in 2015. This is a lot of data. And so they need 100 million PCs to process this data, which requires massive software engineering skills to bring it all together. But it's even more fundamental than that, because they are developing and changing the hardware on the fly. And so the software engineering solutions in this setting up of this have to be adaptable and portable, because you can't guarantee that the hardware that you're currently developing the software on is going to be used in the final solution. So I mentioned before, massive parallelism is required in a solution such as this. And also, one of the things is that the hardware that is used is actually very much requires actually specialist learning to use the hardware itself, but the software engineering solution has to create something at a higher level, so that people who don't have the knowledge about the hardware are able to use such systems. Okay, so the software engineering in this is basically that the skills of the software engineer is to create these portable, accessible systems so that the scientists can focus on collecting the astronomical data rather than worrying about the accessing of the data. So it is a huge undertaking that which software engineers are very much at the heart of. So I've just gone and given you 3 different examples of what software engineers do and the kinds of skill sets that we provide for you in the University of Auckland to do the degree. I'll now just sort of talk about some of the more pragmatic aspects of software engineering that people often ask questions about. So yes, there is a huge demand for software engineers, and it's been very consistent over almost the last 10 years now. It's an area where year after year the industry is saying we need more software engineers. And the pay for software engineers is very good. Okay, now what I've got here is actually the pay scale of a senior software engineer, which the median is about 94,000. But I came in as the senior software engineer because I wanted to make this point here, that for some people within 1 to 4 years of their graduation, they are senior software engineers, okay? And then the next lot of, big chunk of senior software engineers is within 5 to 10 years of your graduation. So both the career prospects, the career growth, and the pay is very positive, if that's what is important to you. I mean, engineering is really about making the world a better place, and I would hope that that's part of your interest in being here, listening to this talk. Now, the next thing that I wanted to talk to you and spend a bit of time on is the difference between software engineering and computer science, because this is a question that I get asked a lot, because both computer science and software engineering is about working with software. I'm going to focus on what software engineering is. So, software engineering, the key thing about this is engineering, okay? We're here to build professional engineers. So what that means is that in addition to sort of learning the state-of-the-art techniques about software development, there's another part when you do an engineering degree which is about your development as a software engineer. That's laced through all of the courses that you do, but some of them are specific general engineering courses, and you're taught with all of your engineering cohort. And in these courses, such topics as communication skills, extremely important, whether you're working in a large team or whether you're communicating with your clients. Communication is key to being a good engineer. And also things like ethics, absolutely core to being an engineer. And software engineering, absolutely imperative. As you saw on the Internet of Things video that I showed you, the fact that there's all of this data constantly being collected from people as we're now sort of just walking down the streets with our iPhones and our smartphones and our Androids, etc. How is that data stored? Who is storing it? Why are they storing it? And who can see that data? Okay? They are really important questions that, as engineers, they are fundamental to how we develop things, because we are about the protection of the individual, about the safety of the individual. Okay, so these are compulsory courses. These are compulsory topics, compulsory things that must be thought of when you do a software engineering degree. Computer science may well have courses that touch on those, but they're never compulsory, and they're never presented. They're not presented in the under the framework of a professional engineer. We have a professional engineering body called Engineering New Zealand, and that body assesses our degrees every 5 years. Every 5 years we have international and national engineering experts coming in to our university, and for every one of the 9 programs that we have in this faculty, they rigorously go through every single course in both undergraduate and postgraduate, assessing the fact of whether it is good quality education and whether it is properly preparing people to be professional engineers. It's a very rigorous process, and because we go through this process, what that means is that we know that our degrees are benchmarked against degrees internationally, and what it also means is that because it's this professional, rigorous process, we have reciprocal agreements with engineering bodies all around the world, including those in the US and in Europe, which says that if you have a degree at our university, it is recognised straight away in these other countries. And that's really powerful, because when you have degrees like medicine, if you study in one country, you have to be re-registered in another country. That's not the case if you do an accredited engineering degree with us here. And the accreditation process, as I say, also ensures that our topics, our education is what industry wants. In 2016, with my colleague Kelly Blinko, we did a survey to industry asking them what are the top skill sets that they want from our software engineering students. And we got answers like software quality and software design and software testing. But can you see here that it's those general skills which are dominating, the communication skills, problem solving in teams, professionalism, ethics, working in teams. They're really important skills to industry, and when you do an engineering degree here, we spend a lot of time focusing on furnishing our students with that skill set, those skill sets. So it's part of our it's part of our teaching pedagogy. In that same survey, we asked industry, do they see a difference between computer science graduates and software engineering graduates? And their answer is yes. we said to them, do you see a need for both computer science graduates and software engineering graduates? And their answer was also yes. Okay? Both are very valid, different ways of getting into the software industry, but my focus here is telling you about the software engineering degree and the skill set that you will get and is embedded into your program in a systematic and constantly reviewed way. So just a few other final things. The degree is taught in the Department of Electrical and Computer Engineering. We actually have 3 programs that we teach in engineering: Electrical and Electronic Engineering, Computer Systems Engineering, and the one that you're all listening to is Software Engineering. Now, just as an aside, our department is in the process of changing our name. So in the next few years you will see that software is added to the name of our department. But even though it's not there in the title even right now, it is a very important and core program in our department. One of the things that makes software engineering a bit different than some of the other engineering degrees is that it's actually taught it actually has lecturers both from electrical and computer engineering, which is where I am in, and we run the program, but it also has lecturers from computer science, thereby making sure that in the software engineering degree, people are taught by practitioners who are at the state of the art in the area, both in terms of the science of the software as well as in the engineering. Our students in software engineering are an incredible cohort. They are very, they also very self-organising, and they've created a very energetic and lively student association. And in the student association, they've got strong links to industry. They have alumni, if you like, from previous students. They have social events. They have events where they help students create CVs for industry. They have, they have mentoring type events as well. So it's a very active association. There's also the IEEE, which is another organisation, professional organisation for both professionals and students, and for all 3 of our different programs. It's American based, but internationally attended, if you like, or membership's international. And the other thing is that our department also encourages sort of social activities, including barbecue lunches, which happen several times in the year, and our final year students have a Part 4 dinner. I'm here mainly to tell you about teaching, because our passion is to create world-ready software engineers. But of course, our own academics are actively involved in software engineering research themselves. And so we have a group working on parallel and reconfigurable computing, and actually they're involved in the Square Kilometre Way project. And then we've got other academics working in software engineering processes, software engineering tools, and software engineering applications. And all of these people have got international connections. They're internationally respected as well as nationally respected. So they are top quality researchers, but also top quality teachers. So if you'd like to know just a little bit more about what our students would do, we have on the September the 14th what we call an exhibition day, which is when our final year students present to the public the year-long projects that they've been working on. And our software engineering students will be presenting there along with our computer systems and our electronic students. So it's on the Friday as I say, for the 14th of December between 1 to 4 p.m. in the Newmarket campus. And really recommend that if you are interested to go along to that, and you'll get to see a huge amount of different research projects and the kinds of things that you could look forward to if you studied doing software engineering. So in conclusion, I'd just like to leave you back again with the quote made by Grady Booch and ask you all what your story will be. Thank you very much. I'll be down here if you want to ask questions. In my experience is people don't like asking questions handing up. So if you want to ask some questions, I'll stay down here.